So in 9.1, we learned about circles and parabolas. In 9.2, it's all about ellipses. So an ellipse is the set of all points x, y in a plane, the sum of whose distance from two distinct fixed points, which are going to be our foci, is constant. So the line through the foci intersects the ellipse at 2 points called the vertices. So we have two vertices here, which is the major axis, which major will always be the longer one. And then we have a minor axis, so minor will be the shorter one. And then we have a center of the ellipse, which is the midpoint of the major axis. So the standard form of an ellipse centered at 0, 0 depends on whether the major axis is horizontal or vertical. So we can have either one.
How would you know which one's the major?
We'll get there. The major is always longer, but I'll show you how we can tell if it's going to be horizontal or vertical. For this picture, when we do all of our ellipses equations, we're going to have an A, B, and C. So C is the distance from the center to the foci. A is going to be the distance from the center to the vertex on the major axis. And B is the center to the vertex on the minor axis. So notice how in the first picture, A is the distance from the center to the vertex on the major, so it goes horizontal here. But our major axis can also go vertical. So major is always the longer one. Sometimes it'll be horizontal, sometimes it'll be vertical. And I'll show you on the next couple slides how we can tell which one it'll be. And also the foci. So foci is just plural of focus, but the foci are always, always, always on the major axis. So those can either go horizontal or vertical. They're always on the major. All right, so these formulas, this page, applies when our center is at 0, 0. Our A is always greater than the B, because A is what is the length of the major axis. It'll be 2A, so it determines our length. So if our bigger denominator, so looking at these two, horizontal and vertical, if our bigger denominator is under the X, then it's going to be a horizontal ellipse. If the bigger denominator is under the Y, it'll be a vertical ellipse. So that's how we tell the difference. We can use this formula to help us find either A, B, or C. If it gives us the formula here, the standard form of the equation of ellipse, we would use this formula to find C. And remember, C helps us determine the distance of the focus. And then also, the length of the major axis is 2 times A, because remember, A is the distance from the center to the major, so it would be 2 times whatever that distance is to find the length of the whole major axis. And then the length of the minor axis is 2 times B. So we'll use this formula a little bit more because our center is not always going to be at 0, 0. So here's our center. Our center is HK. So remember, H goes with X, K goes with Y, because H is in the X position, K is in the Y position. So even when we have a vertical one, Don't switch these up because now K is coming first. K goes with the Y, so our center will still be H, comma, K. So we'll use these formulas more because our center is not always going to be at 0, 0. And then this is a little ellipses cheat sheet, so it's kind of everything you need to know. So it depends on what we're given, but step 1 will usually be to plot the foci. So determine if it's horizontal or vertical. So remember, foci are always on major. So if our foci go this way, then we know we have a horizontal ellipse. If our foci go up and down, we have a vertical ellipse. We can find the center, which is HK. If it's not given to us, we can take the midpoint of the foci, and that's our center. So center will always be right in the middle of the foci. We want to identify A, B, and C. So A is whatever the length of our major is divided by 2. C is the distance from the center to the foci, so we could use this formula to help us find either A, B, and C, because 2 of them will usually be given, and we'll have to find the third. And then, again, bigger denominator determines if it's horizontal or vertical. And then also notice, I forgot to point this out in our equations, your equation of an ellipse will always be equal to 1. Always, always, always. So we need... All right, so example 1. Find the standard form of the equation of the ellipse having the foci at 0, 1 and 4, 1 and a major axis length of 6. So let's start by plotting the information that we have. Make a little graph here. I'll plot my foci, so that's at 0, 1. Stay at 0, go up 1. And then 4, 1. So 1, 2, 3, 4, 1. So there's my foci. Given my foci, what do you think I could find next? The center. So center is going to be right in the middle of the foci. So if the length between the 2 foci is 4, where would my center be? Halfway. What's halfway? What point? It'd be 2, 1, because it's up 1. So 2, 1 is the center.
And how did you find the center?
It's the midpoint of the foci. So we could do the midpoint formula, which is x1 plus y1, x1 plus x2 over 2, and then y1 plus y2 over 2. So you can do that, or you can just count, because we have 4 spaces in between, so if I go 2 to the right, that'd be the middle. So that's our center. Next, we want to figure out what A, B, and C are. Is this going to be a vertical ellipse or a horizontal ellipse? Horizontal, because our foci are horizontal, so we know it's going to be a horizontal ellipse. So our major axis is going to be horizontal. If our major axis has a length of 6, what is A?
3.
3, perfect. Because the whole major axis length of 6 is the length of 6, but from the center to one vertex on the major axis will be half of that, which is 3. So we can count 3 from our center, 1, 2, 3. And then 3 from our center this way, 1, 2, 3. And that's our point there. Oh. Bless you. Now, what's next? Do I have anything to determine B or C? C. C is the distance from the center to the foci, to one of the focus. So what is the distance from the center to one focus? 2. So C would be 2. And then I have a handy little formula to help me find the missing one. So that is c squared is equal to a squared minus b squared. So 2 squared is equal to 3 squared minus b squared. So 4 is equal to 9 minus b squared. I can subtract 9 on both sides, so negative 5 is equal to negative b squared. Divide by negative 1, so b squared is equal to 5. So what is b? Square root 5.
So what exactly is B showing?
B is the length of, or the distance from the center to the minor axis. So we would go up square root 5, which would be like 2 something, and then down square root 5, so it'll be like down here. So there's our ellipse. We didn't have to graph it, but it helps to graph it to determine where everything is. But we do have to find the standard form of our equation. So our equation is x minus h squared plus y minus k squared. The x is over a and the y is over b, and it's equal to 1. Thank you. How did I know that the x was going to be over a? Since it's horizontal. So the bigger number is going to be under the x. Yes. All right, so let's plug in what we have. Do I know what h is? Yes. What's h? 2. Remember, h and k come from the center here. So h is 2, and what's k? 1. So we can plug those in. Oh, and sorry, my formula is a squared and b squared on the bottom. So what is a squared? What's a? So this is a, b, and c. So a is 3. So a squared would be 9. So 9 goes on the bottom there. And then b is square root 5. So what is b squared? Just 5. And this is our equation. So example 2 says, sketch the ellipse given by the following equation. Identify the center and the vertices. So we want this to be in the standard form for our ellipse. So our standard form, I'll write it on the side here, is x minus h squared over a squared plus y minus k squared over b squared is equal to 1.
How do we know that we're using the minus h first instead of the minus?
We don't, but just like once we get our equation to rearrange and look like this, we'll be able to tell if it's a vertical ellipse or a horizontal ellipse. So like right now we can just use this, and then whatever number is bigger on the bottom will be what determines that. So what do you think I should do first? I want my equation to look like the standard form here.
Should you isolate the y and then factor the 4x squared and 36?
No, it's actually easier than that.
Are we completing this correct?
No.
3 subtract 35 is equal to 1.
Instead of subtracting 35, what else can I do to make that equal to 1? Divide by 36. So again, I want it to be equal to 1, so I'm going to divide by 36. So divide everything in your equation by 36. Yes. Yes.
What is it? Why is it equal to 1?
That's just the way our formula is. So I can simplify 4 over 36 to what? 1 over 9. So this will be x squared over 9 plus y squared over 36 is equal to 1. And there we have it. That's our standard form. So what's our center? 0, 0.
And we know that because
Because we're not adding anything to x. If your x and y are the only things that are squared, and that's the only x and y that you have, you won't have to complete the square. And you can just assume that's your 0, 0.
And then since the bottom of y is
Yes, awesome. So since our denominator for y is bigger, that means it's going to be a vertical ellipse. So that means, remember, a squared is always the bigger one. So a squared is 36. So what is just a? 6. We would just take the square root.
so it's plus or minus 6.
But we don't do like negative, because we're dealing with the distance, so we don't deal with negative distance, but we do go in both directions, 6. So which way am I going 6? Up, down, left, or right? Up 6 and down 6, because that is the length, or the distance from the center to the major. And I also have b, which is the other number here. So b squared is equal to 9, so what is b? 3. Just take the square root of 9. So that's 3. So b is the distance from the center to the minor. So from the center, I go 3 to the right and 3 to the left. And the last thing I need to find is the foci.
We do that with the c squared.
Yes, so our formula is c squared is equal to a squared minus b squared. So c squared is equal to 36 minus 9. So this would be 27. So c is square root 27. It should be 5 something. So c would be, if we broke this down, this would be 9 and 3. And 9 is 3 and 3, so it'd be 3 square root 3. So it'd be 3 times whatever the square root 3 is, which it's actually like a little bit more than 5.
So we'll have a calculator for this, I'm assuming, so we can like estimate distances.
So the distance from the center to the foci is about 5-ish. So I'll put a point at 5. And there's our ellipse. How did I know that my foci went up and down and not left and right? Because they always go on the major. So foci are always on the major. All right, example 3. Graph the ellipse and identify the center, vertices, and foci. So
Complete the square here.
here we have to complete the square. So I'm going to move the number to the other side just by subtracting 9. And then I have x squared plus, I'm going to combine my x's together. So keep, the x's are always going to go together. So that'll be x squared plus 6x. And then I'll leave a space to complete the square there. And then I have 4y squared minus 8y. And I'll leave a space to complete the square there. And it's equal to negative 9. So what's the little formula that I use to complete the square?
Something with
B over 2 squared. So for the x's, what's my b? 6. It's the middle number. So 6 over 2 squared. 6 over 2 is 3. And what is 3 squared? 9. So I'm adding 9 on the left side. I also have to add 9 on the right side to keep my equation balanced. So then in my parentheses squared here, what's going to go inside? So remember, it's the number that's squared, or the term, whatever, that's squared here, and the number that's squared here. So it should be x plus 3. All right, the y is a little bit different because I have 4y here. So what do you think I need to do first? Divide out the 4. So I'm going to take that 4 to the outside, and then I have y squared minus 2y, and then a space there.
And we don't do anything to the negative 9?
Not yet.
Okay.
Because we added the 9 to it, and we'll add whatever we get from here to it also. And then I'll just add those at the end. All right, so in my space, I have b over 2 squared. And what's my b now? So negative 2 over 2 squared. So this is negative 1 squared. And what's negative 1 squared? Positive 1. So I'm adding 1 on the inside, but what is happening to that 1? It's getting multiplied by 4. So what am I actually adding on the inside? Or on this side, the left side? I'm actually adding 4. So I'm adding 4 on the left sides here. So I have to make sure I add 4 on the right side also. Because we have a 4 on the outside, so you have to multiply that 4. All right, so now in my parentheses squared, what's going to go inside? Y minus 1. And what am I missing? The 4 on the outside. Remember, if you took something out, it needs to go on the outside too. And then I can add everything on the outside here. So I have negative 9 plus 9 plus 4. So what is this all equal to? 4. In my standard form of an ellipse, what does it have to be equal to? 1. So how can I get it to be equal to 1 instead of 4? Divide everything by 4. So my x will be x plus 3 squared over 4. The 4's cancel out here, but I'm still going to write a 1 on the bottom just so we can make it look like our standard form. You don't have to. It would still be correct if you didn't. Kind of just help us see it. I'm going to put a 1 on the bottom. All right, so now let's identify everything that we have. What's the center? Negative 3, 1. So I can put that on my graph. I go to the left, negative 3, up 1. There's my center. What is A? Perfect. A squared is 4, so just A would be 2. And A is the distance from the center to what? To the major. Am I going vertically or horizontally here? Horizontally, because A, the bigger denominator, is under the x, so that means I have a horizontal ellipse. So I'm going to go to the right 2 from the center and to the left 2.
And when you say from center to major, is that like your ending point on your major axis?
Yes. Yeah, so it's like from the center to the vertex on the major. All right, now let's figure out B. B squared is what? 1, so just B is 1. So I'm going to go up 1 and down 1. And then lastly, I can figure out C. So C squared is equal to A squared minus B squared. So C squared is 4 minus 1. C squared is 3. So just C would be square root 3. So it's less than 2. So it'd be in here somewhere.
And that's your focus?
That is my foci. So to identify my points, so my vertex on the major,
What do you mean by that? Because like I'm used to vertex being like
so like the red points here, end points on the major, yeah. The center came from H and K on the inside, but we have to flip the signs. So for circles, parabolas, and ellipses, you always flip the signs of H and K for all three of them. So I have to identify the points for my vertex on the or my vertices, I guess, because there's two of them on the major. So what would those 2 points be? Perfect. -5, 1, and -1, 1. So once you graph it, just look at the graph and see where are those red points. That's my vertices on the major. And then my vertices on the minor were determined by B. So those are my blue points. So what are my 2 blue points? -3, 2, and -3, 0. And then the last thing that we have to find are foci. So we know where they are on our ellipse here. But what points would they be? So we go √3 from the center to the right and to the left. So it would be -3, and then we can say plus or minus because we have 2 of them. So we're adding 3 to go to the right. We're subtracting 3 to go to the left. So it'd be -3 plus or minus √3, comma 1. If you wanted to write them separate, you could write them separate too. So it'd be -3 plus √3, -3 minus √3, comma 1.
I don't know if we're gonna have them like.
If it didn't cancel out, let's say we had 4 over, let's say we divided by 10. You can change this and move the 4 as your denominator to the 10, because if you keep change flip the denominator, it goes back to the top. So now 10 over 4 is your a squared or whatever, if this one was a. So if you had something that was still left, you can bring it to the denominator of your denominator, I guess.
Okay.
Which you would simplify, but just as an example.